So go ahead and phones, earbuds, all that should be away, click and close. And I want to just go through a little something with you today. So short day today. I'm not going to try to do too much. Here's the plan for today. We want to come up with our strategy or our technique for solving absolute value inequalities. But we're not going to actually finish the whole problem. We're not going to solve them. We're just going to set up the method for solving them today. And tomorrow we'll go a little further and actually get some experience solving these inequalities. So first things first, let's go back and maybe review. Let's review how we solve the absolute value equations first of all. Okay, so what if I were to give you an equation like this? What if we had something like the absolute value of x minus 1, say 2 times that, equals 22. Okay? We want to solve that absolute value equation. What's the first thing that we would do in that situation? Okay, we divide by 2. How come? Perfect, because we have to isolate the absolute values. We can't do anything inside the absolute values, right? So the very first step is going to be, we're going to divide both sides of the equation by 2, which is great. And that gives us the absolute value of x minus 1 equals, what, 11? Okay, so there's, so far, that's the first thing we do is always isolate the absolute value, right? There's the first part. Okay, once we've isolated the absolute value, then what did we do? Then what we do? We can't go any further until we get rid of the absolute values, right? We can't do any algebra inside the absolute values. Okay, so there's a temptation to make that a +1 because we have absolute values there. But we can't do that because that's doing stuff inside the absolute values, right? What do we do?
Didn't you put negative?
Okay, so we're gonna set up 2 equations. The next part is, if this is part 1, part 2 is set up 2 equations. And here's the important thing. 2 equations and there's going to be no absolute values there, right? Setting up 2 regular equations. So what are my 2 equations going to be? We get equation 1 and equation 2. What's equation 1? Yes?
X minus 1 equals 5.
Okay, good. So whatever's inside is going to equal either 11, so we get x minus 1 equals 11, or equation 2 over here. Let's just put like a line down here so we can separate the 2. Equation 2, whatever is inside, which is x minus 1 equals negative 11, right? And then all we had to do from there, so that's part 2 is pretty easy. We don't really, all we're doing is setting up the equations that we're going to solve. And then finally, we get down to part 3. Part 3, whoops. Part 3 is just solve the 2 equations. Right, we won't even mess with that. That's easy to do. Right? Just add 1 in both cases, don't we? Right, so what would we get? If we add 1 here, we get x equals 12, or, we need an or in the middle, don't we? X equals, what's negative 11 plus 1? Good, so there's my 2 equations, right? For my 2 solutions. Okay? Good, so now what we're going to move on to is what happens if instead of having an absolute value equation, what if we've got absolute values and inequalities instead? The part where people have trouble with this, what they'll forget is there's two patterns that go with the different kinds of absolute value inequalities. We could have a situation where we have an absolute value that's greater than a number, or a situation where we have an absolute value that's less than a number, right? Each one of them calls for its own pattern. They're different, and it's easy to forget which one goes with which. So let's spend a few minutes and just kind of figure out how we can always remember that. Without having to memorize a fact that you'll forget, how can you attach that to something that you will remember? Here's a good example. It might help. So let's take this situation. If you can throw a rock 100 feet, what are the places you can hit on your street if you wing that rock either up the street or down the street? So if I step out my front door and I throw a rock up the street, I can throw 100 feet. It's just going to land 100 feet up the street, right? If I throw it that way, it's going to land 100 feet down the street. So if I'm limiting myself to only throwing onto the street, it would just look like this, wouldn't it? There's one possibility. And if I throw it this way down the street, there's another possibility, right? Okay, so we get, there's one outcome, there's the other outcome. If we make this a little bit mathematical, just to help us out kind of organizing our thinking here, if we make this a little bit mathematical, let's say that we're gonna say that this is the positive direction on our street, just like the positive x-axis, right? Let's say that when we step out our door, our position is 0. We're starting from nowhere, starting from 0. Where is the rock going to land if I throw it in the positive direction up the street? 100. If I throw it in the negative direction? Okay. What's the distance from where the rock hits to where I throw it in both cases? How far would an ant have to walk to get where it hits?
100 feet.
100, right? So the distance, in both cases, the distance where the rock lands from where I threw it is 100. It's just either going to land at negative 100 or positive 100, depending on where I throw it. Okay, so this is a representation of that absolute value equation, right? And here's why. Because when we talk about an absolute value of x, the absolute value of x really means a distance. It's a distance from 0 on the number line. That's what that stands for, right? So when I say the absolute value of x equals 100, that's telling me that the solution to that is going to be the places that have a distance of 100 from 0 on the number line. Well, we already know what the answers are, right? We already know we split this up and we get either x equals positive 100 or x equals negative 100, right? Okay, if we want to write this as two equations, there they are, okay? Now let's take another case. So we know if we throw it 100, it's going to land in one of those two places. Let's ask ourselves, oh, and here's kind of the mathematical way of saying that. If we've got the absolute value of u, or u could be anything. In our case, in a simple case, it's just an x, but it could be a 2x plus 7 or a 9x minus 3 or something like that, right? If we have an absolute value of something is equal to a number A, whatever that wants to be, then the solutions are always going to be whatever's inside, call it u, equals the negative number or equals the positive number. You already told me that earlier, okay? Well, how do we extend this to inequalities? Then we ask a different question now. Same deal. We're going to step out the front door, and there's up the street in the positive direction, there's down the street in the negative direction. If I can throw 100 feet, I'm asking a different question now. What are all the places on my street that are in my range? What's that going to look like in terms of the picture? So here's as far as I can throw. Up the street, down the street. So if I had to shade in all the places that are in range, what would that look like? Okay, I've seen some people doing this kind of thing. So it's everything in between my maximum range in the negative direction, my maximum range in the positive direction, right? Everybody agree? Okay, so that's like saying, I'm asking the question, what are all the distances then that are what? Related to 100. They're what compared to 100? So this is 0. That's 100. That's negative 100. What am I going to say about the absolute value of x? Absolute value of x here, which is the distance from 0, has to be what in this case? Not just equal to 100, but what else? Yeah, right, does that make sense? Doesn't that make sense? Now I'm asking in an absolute value equation, in an absolute value equation, I'm just representing the situation where the distances from 0 are less than or equal to 100. Because I don't have to throw my maximum distance. I could throw less than that to hit a place that's closer, right? So that's our way of saying all the places that are in range of 100, isn't it? If we have an absolute value that's less than or equal to 100, we want distances that are 100 or smaller. So everything that's in that range, in that region, right? Okay, what does that translate to? Now think about what's graphed up here in red, and let's graph that not as an absolute value inequality, but let's graph it as a regular compound inequality. So there's my two inequalities wrapped up in one compound inequality. Just like before, we traded the equation, the absolute value equation, for two regular equations in both of these examples, right? Now we're going to trade our absolute value inequality for two regular inequalities. How do we say that red interval? It starts at negative 100 and it ends at positive 100. Is that an and or an or? It's an and, isn't it? Because there's two conditions here. I have two endpoints, and so I need to say two things about that single interval. I have to say, what are those values greater than, right? So they're greater than the smallest value, and they have to be less than the biggest value, right? So doesn't that look like, if I were to write that as a compound inequality, wouldn't that look like x is greater than or equal to what? Negative 100, and there it is. And x is less than or equal to positive 100. So what's the moral of that short story then? The moral of the story is, whenever you have an absolute value is less than something, you always know you're going to get an and compound inequality, right? Whatever started off inside the absolute values is in the middle. It's going to be greater than or equal to the negative number and less than or equal to the positive number, if you're including the equal sign. If there's no equal sign, well, we wouldn't include it there either, obviously, right? Here's our way of saying it mathematically. If the absolute value of something, call it u, is less than or equal to some number a, then that's represented by an in-range and type compound inequality, isn't it? So we got two endpoints, and here's how we write it. Whatever's inside is greater than or equal to the negative and less than or equal to the positive. Okay? Well, what about the other possibility? What if we ask the question, now, let's come up with a graph of all the places that are out of my range, that I can't hit with the rock. What's that going to look like? Okay, everything that's too far away, that's too far in the positive direction or too far in the negative direction. Right? So here's my, once again, same picture. Oops. So there's how far I can throw in the positive direction. There's how far I can throw in the negative direction. Only now I want all the places that I can't hit. So it's going to be everything, what? Greater than 100, right? Or everything less than negative 100. Now that's an or statement, isn't it? Because I've got two separate places. You can't be in both places at the same time. Each one of those graphed parts only has one endpoint. And so each one of those is a simple regular inequality, but it's an or situation where I have one or the other, right? So how would I say this using an absolute value inequality? The distance now, so the absolute value of x is what? Greater than 100, isn't it? Right? That makes sense, right? We've got this. The distance from the origin, the distance from 0, has to be greater than 100, so it's out of my range. And how do we write that as a compound inequality? Well, this is, remember we talked about this last week. This is like when you see two of them going out to the side like that. It's like the oars on a boat that's rowing at you. That's an or inequality, right? So how do I say this one again? I'll start with this one. What's this one going to be? Okay, x is less than negative 100, or up here we get x is greater than positive 100, right? And that's how that's always going to work. Whenever we have something, an absolute value is greater than a number, we always know the outcome is going to be, we're going to end up with an expression where whatever's inside has to be greater than the positive or less than the negative. It's out of range picture, okay? Here's how we say it mathematically. We have the absolute value of something, call it u, could be anything, is greater than a number, then whatever's inside, call it u, is either going to be less than the negative number or it's going to be greater than the positive. Okay, so on your little handout, let's just fill a couple things in there. So what if I've got the absolute value of x is greater than 7? Greater than or equal to? Yes, sir. Yeah, right that. So how do I graph that? The absolute value of x is greater than or equal to 7. How would I graph that one? Okay, close dots at 7. One to the right, okay. What's the other possibility? Okay, back at -7, going to the left. That's an outer range picture, isn't it? We want to know where is the distance greater than or equal to 7. So big distances that are out of range. Okay, if I write that as a compound inequality, we just did one like that. This is going to be either x is less than -7 or x is greater than +7. And if I write it with interval notation, how do I say that part? I got my comma, I got what for this part that's graphed right there, what's the left end point? Good, -infinity, what's the right end point? And I can include it, so we put a bracket, good. What do I use for my or symbol if I'm using interval notation? Okay, I heard it. The U, yeah, good, my union symbol. And then up here we get there we go. Good. Okay, what about absolute value of x is less than or equal to 4? Okay, is that in range this situation or out of range? In range, good. Okay, so we're going to close dots where? Okay, so -4, +4. And what do I do? Reconnect. I want to know where the distances are small, where they're less than or equal to 4, so in range. Written as a compound inequality, what would I do? X is greater than or equal to -4 and less than or equal to 4. Right? So writing it with interval notation. Now, the and ones are super easy with interval notation. What's that going to look like with interval notation? Bracket -4, 4, bracket, good. Okay? So for today, we'll come back to this tomorrow, but for today, in the steps to solving absolute value inequalities, we're really just going to we're going to isolate the absolute value, and then we're going to create two cases, and that's it. So what you're going to do now, you're going to go into your Chromebooks. You're going to there's a really short, and you're going to like this. I took the homework assignment and I took all these problems out of the homework assignment, so you don't have to do them in the homework assignment. The e-ticket for today is not a paper one; it's on Moodle. So you'll go into Moodle. It'll say A 1.6 e-ticket, and these are the kinds of questions you're going to see. They're going to look like this. So the first 5, everybody look up here and just go through one. I mean, you get through this, you'll finish this today. But I want to do just an example of each with you. So this first one, right? If we have the absolute value of something, in this case the absolute value of -3x plus 6 is less than 1, all they want you to do is pick the way that I'm going to write that absolute value inequality as a compound inequality. What's that going to be? Is that going to be an in-range or out-of-range situation if I have a distance that's less than 1? It's an in-range, right? So and or then. Let's see, let's get some hands here. Everybody's got a vote here. Raise your hand if you say it's and. In range, yeah. Okay. Raise your hand if it's out of range, if it's an or. Okay. All right, so we're good. So then that's going to be one of the and ones, isn't it? Whatever, if I have an absolute value that's less than a number, whatever's inside is going to go in the middle, and it's going to be, and this doesn't have an equal sign, so it's got to be number 2, doesn't it? Right? Whatever's in the absolute values has to be greater than the negative and less than the positive. That's our setup. What would we do from there? Same stuff you've been doing. Solve the inequality then, but that's for tomorrow. For now, the answer is just 2. Right? It's example 2 is what that would become if I made my transition to 2 inequalities. Okay? How about that one? If I have an absolute value of something is greater than a number, is that an in-range or out-of-range situation? Out of range. So is that an or or an and then? That's an or, right? Those are the graphs that go away that are big. So that's an or. So which one's it going to be then? Now, 1's the equation. It's not that one, is it? But which one of 4 or 5 is going to work? It's going to be 4, isn't it? Whatever's inside is less than the negative, or what's inside is greater than the positive. So that's a 4. Okay? How about the last 2? Let's look at these. So the last 2, they're asking you to not solve it, but just set it up. So in this case right here, I've got an absolute value of some stuff is less than or equal to 6. In range and or out of range or, which one is it? If it's an absolute value that's less than, so the distance is less than 6, less than or equal to 6. What's that going to be? Raise your hand if you say it's an and, in range and. Okay, raise your hand if it's an out of range or. We got it. Okay, so it's got to be an in range one. So I'm going to start in the middle. I've got my 2x plus 8. Now what am I going to say about that? Either it's got to be, in this case, it's got to be greater than or equal to. So I'll come back here and add my greater than or equal to. Greater than or equal to the negative, right? Everybody agree? And it's got to be less than or equal to the positive. So that's how I set it up. That's all they want. They don't want you to solve it. They just want you to set up the and compound inequality or the or one, if that's what it ends up being. Okay? Go. And I'd like to see those done by the end of the period if possible.
Can I get a drink of water?
Yeah, absolutely.